My name is Gajendra Deshpande, and today I will be presenting a talk on securing Django applications. So, in today's talk, I'll be discussing about security aspects of Django web applications. Basically, these are the security aspects of any web application, not only just Django, but we will be speaking with respect to Django. Then penetration testing of Django web applications. Then overview of OWASP top 10 risks. So as we know that OWASP top 10 risks applies to all the web applications. So Django is no exception. So these applies to even Flask web applications or even PHP based web applications or even WordPress based web applications. Then we will discuss two tools in brief. They are Djangohunter and Django Goat. Then strategies and configuration settings to make Django applications secure. Okay, so these are the topics which we are going to cover in our discussion today. Of course, we will not be covering these things in a sequence. So we will pick a WASP top 10 risk and we'll discuss the risk and we'll discuss the possible solution. Now let us start with this website. This website is known as djcheckup.com/pony. So you can visit this site and you can type the URL of Django website. Okay, and when you click on run checkup on my site, right, it will go through the website of the URL mentioned, and if there are any issues, it will list. So this is what you are going to see. So of course, I'm not going to display the website I have checked for. So it says that there are some improvements needed. Okay, for example, they have one recommendation. When you see thumbs up, that means that particular issue has been taken care. For example, debug is not enabled. In HTTP redirecting to HTTPS, HTTPS is enabled, HSTS is enabled, and so on. So similarly here on this screen, you can see that there's a code which has been put in the red box. Okay, so here it is shown that secret key is something and you need to keep it really secret. So you should not be disclosing it. And debug option is set to true here. Now note here that it's very important. When you are in development mode, you can set it to true because you want to see what are the errors, what are the exceptions. But when you are deploying your Django application, you need to set it to false. So that's why in the previous screen, also you might have seen, it says that debug is set to false. Okay, it's set to not true. So what happens if you set debug equal to true in production environment, right? So hackers will be trying to find out the vulnerabilities. So they may try something and they may get some errors. So when they get some errors from that error also, they can make out some information that which can be used to carry out further attacks. For example, the server details, the server operating system details, and so on, or the Django version, and so on. So that's why when you are deploying the application, you need to set debug equal to false. Then these are the top 10 OWASP vulnerabilities. So first one and the most important one is the injection. So there are different types of injection attacks. We'll see what are those and how they are carried out. Then we have got broken authentication, then sensitive data exposure, XML external entities, broken access control, security misconfigurations, cross-site scripting, insecure deserialization, then using components with known vulnerabilities, and insufficient logging and monitoring. Now let us first see the injection attacks. So there are lots of different types of injection attacks are there, and the most popular one is the SQL injection. So SQL injection is a type of attack where a hacker is able to execute arbitrary SQL code on a database. Note here that this arbitrary SQL code is a malicious code. Okay, so this can result in records being deleted or data leakage. Okay, so most of times it is used for data leakage. And injection vulnerabilities can be found at various places. It can be found in SQL, it can be found in LDAP, XPath, NoSQL queries, operating system commands, XML parsers, SMTP headers, and so on. Then injection can result in data loss, corruption, or disclosure to unauthorized parties, loss of accountability, or even denial of access. It can sometimes also lead to complete host takeover. Now, this is how the SQL injection attack is carried out. Right? You can see here that the first line SQL query has been mentioned. So string query is equal to select star from accounts, where customer ID is equal to request.get parameter of ID. Okay. So at the end of the query, we are going to use malicious input. So that's how it has been used in the next line. Okay, example.com/app/account view ID is equal to, and you can see here that or1 equal to 1 has been mentioned. Okay, so the malicious code has been injected here. Okay, so now we know that how OR operation or OR operator works. So in this case, whatever may be the left hand side query, it's going to result into true, and it's going to reveal the information. Of course, this is not a valid malicious input. It's not so simple. Okay, so if you Google and if you go to GitHub, you will get lots of or a huge list of injection commands. So one of them will work, or sometimes you may have to craft it. Now, the solution is to use query parameterization. We will discuss it on the next slide. Okay. So if you are using Django, then there are two things. One is extra and raw SQL. These functionalities you can use if you are writing custom queries in Django. So how you can achieve protection against SQL injection attacks? First one is query parameterization. Okay. And it is available by default in Django. That's a great feature. Then use extra and raw SQL with caution. So you can use it only when it is really necessary, when you have no other option. Right? Then use positive or whitelist server-side input validation. Again, it may not be the complete defense, but input validation is very, very important. Many times SQL injection attacks happen because of incomplete or insufficient input validations. The next is the broken authentication. So attackers have access to hundreds of millions of valid usernames and password combinations for credential stuffing. So default administrative account lists, automated brute force, and dictionary attack tools. So they use tools basically. Now these are also known as session management attacks. Now the important thing here is that, of course, they will get access to hundreds of millions of accounts, but they need not have to log into all those things. They just need to log into one account, that is the admin account, to compromise the system. Okay, so they need not have to log into or access hundreds of accounts. So just gain access to the admin account or super admin account, and you can, and a hacker can do the damage to any number of accounts or the entire system. Okay. Then credential stuffing is the use of lists of known passwords, and it's a common attack. Okay. So you will get these credential stuffing data on dark web, and most authentication attacks occur due to the continued use of passwords as a sole factor. So you should not be using only passwords. Okay. Then application session timeouts aren't set properly. So sometimes they are not set, sometimes they are set as say 5 minutes or 10 minutes, which is not recommended duration. Okay. So how we can achieve protection against broken authentication? So wherever possible, implement a multi-factor authentication. Okay. So using multi-factor authentication is one solution. say for example, getting the one-time password or OTP on your mobile phone or on your email ID, or using no password at all. That is, it will directly work with the help of OTPs. Or you can also use authenticator applications, okay, which keeps on generating the OTPs, and OTPs for a short duration, say just for 20 seconds, and you can use it. So these things prevent automated credential stuffing or brute force or stolen credential reuse attacks. They do not ship or deploy with any default credentials, particularly for admin users. This is a great problem. Okay, so whenever a huge number of accounts are created in an organization, they are usually deployed or shipped with a default password. So it's the responsibility of the user to change those default passwords. Okay, if anyone knows the default credentials, then anyone can log in. So many people have faced a lot of problem because of these default credentials. Okay, then implement weak password checks, such as testing new or changed passwords against a list of the top 10,000 worst passwords. Okay, then ensure registration, credential recovery, and API pathways are hardened against the account enumeration attacks by using the same messages for all outcomes. Then limit or increasingly delay failed login attempts. So you can set a firewall, right, where you can say that after 3 failed login attempts, you can block the login page for few minutes. Then log all failures and alert the administrators. Then use again server side secure built-in session manager. So that generates a new random session ID with high entropy after login. So session IDs should not be in the URL. Okay, be securely stored and invalidated after logout, idle or absolute timeouts. Now, in case of Django, you can use these packages. Okay, you can use Django OTP to generate one-time passwords. If you want to implement two-factor authentication for Django, right, you can just go through the URL mentioned here and you will get the package, right? That is two-factor authentication. Then for user session management, also there are some packages. You can use the package mentioned on this slide, right, to achieve protection against broken authentication when you are developing Django application. The next is the sensitive data exposure. So rather than directly attacking the crypto, attackers steal keys, execute man-in-the-middle attacks, or steal clear uh, text data of the server while in transit or from the user's client. For example, the browser. So here a manual attack is generally required. So generally how this works is, so whenever we are sending the data, right, the application encrypts the information. So in this case, we can consider credit card numbers in a database using automatic database encryption. Okay. However, this data is automatically decrypted when retrieved. So allowing a SQL injection flow to retrieve credit card numbers in the clear text. Okay. There's one more scenario, right? When we are processing the information, it has to be decrypted. What if the client machine is compromised? What if the spyware is installed? Right. So the moment your information is decrypted, right, that can be stolen or that can be stolen. So a site doesn't use or enforce TLS, that is transport layer security, for all pages or supports weak encryption. Okay. So the password database uses unsalted or simple hashes to store everyone's passwords. So these are some scenarios for sensitive data exposure. Now, how you can achieve protection against sensitive data exposure? So classify data processed, stored, or transmitted by an application. Identify which data is sensitive according to privacy laws, regulatory requirements, or business needs. Apply controls as per the classification. Then don't store sensitive data unnecessarily. Discard it as soon as possible, or use PCI DSS compliant tokenization. So this is very, very important when you are especially dealing with e-commerce applications or credit card data. Whenever you are dealing with money or transaction, right? Especially the financial transaction, it has to be PCI DSS compliant. And make sure to encrypt all sensitive data at rest. Then encrypt all data in transit with secure protocols such as TLS. Then disable caching, right? Then use the required strong hashing functions. Then there is one more solution. That is, in case of encryption, there's a new area which is coming up. Of course, there are many people who are working since years. So that is known as homomorphic encryption. So this allows you to perform computations over encrypted data. Okay, that is, you need not have to decrypt the data. You need not have to decrypt the content. Okay, so you can perform computations on the encrypted data. Okay, so there are already existing algorithms which have these properties. For example, RSA is existing since since many years, right? So it has a multiplicative property. So similarly, there are other algorithms which have got additive property. And if you want to perform arbitrary computations, then there is a algorithm by algorithm or system known as Gentry's crypto system. Okay. But the problem is that it is very computation intensive. That's the problem. Okay. Now these are the settings which you can make for Django. These are the SSL or TLS settings. So you have to go to production.py and enable these options to true. Then you can use these packages in Django, that is Django encrypted model fields, right? It's a Python cryptographic library. Then similarly, there is one more Django cryptography library, which is a set of primitives for easy encryption of the data in Django. Then there is symmetric encryption. If you are interested, that's known as Django for net fields. Again, which is using cryptography library. The next is XML external entity attack. So attackers can exploit vulnerable XML processors if they can upload XML or include hostile content in an XML document. Okay, exploiting vulnerable code, dependencies, and integrations. So we know that XML can be used as an alternative to database in many cases. Okay, so similar to SQL injection attacks, XML injection attacks can also be possible. Now, on this slide, we'll see some examples related to XML external entity attack. Okay. So in HTML, we have got the HTML entities which can be used to print special characters, okay, or which have special meaning. So the greatest advantage of XML is that it allows you to create your own elements, attributes, and entities. So you can see here that on this slide, a custom entity has been created, that is &xxe. Okay. And it has been linked to the file called as /etc/passwd. So whenever any user uses this entity, right, so they are getting access to /etc/password file. Okay, so similarly, attacker can probe server's private network by changing the entity line to the private IP address or the private folder which is restricted. Then attacker can also perform denial of service attack by including a potentially endless file. So it's a random file whose content never ends. It's an endless file. Now how we can achieve protection against XML external entities? So wherever possible, use less complex data formats such as JSON, right? And avoid serialization of sensitive data. Then disable XML external entity and DTD processing in all XML parsers in the application. Then implement positive server-side input validation, filtering, or sanitization to prevent hostile data within XML documents. Verify that XML or XSL file upload functionality validates incoming XML using XSD validation or similar. So you need to perform validation at various stages. Right? You can check whether your XML is valid and whether your DDD is valid, and whether your XML is well formed. You can use a tool called as shadow daemon, which is a collection of tools to detect, record, and block attacks on web applications. So it's a web application firewall that intercepts requests and filters out malicious parameters. Okay. It's a free software and it supports Python, Django, and Flask, right? With respect to Python's ecosystem, but it also supports PHP and Perl. The next is broken access control. So the application uses unverified data in SQL call that is accessing the account information. Okay. Now an attacker simply modifies the account parameter here in the browser to send whatever account number they want. So if not properly verified, the attacker can access any user's account. So again, it speaks about the validation of data on the server side. Okay. So here on the next line, you can see here that the account name has been modified with not my account. So attackers simply force the browsers to target URLs. So admin rights are required for accessing the admin page. Okay. So they are simply trying some URLs so that they can get the unauthorized access to the page. Then to achieve protection against broken access control is to use wherever attacker cannot modify the access control, check or metadata, with the exception of public resources, deny by default. Then disable web server directory listing. So many times web server directories are visible. Okay. And ensure that file metadata and backup files are not present with the web routes. Then log access control failures, alert admins when appropriate. Then use Django user management. So when you use user management, you can assign different roles and you can define the access control. That is who has access to what. The next is security misconfigurations. So security misconfiguration is also very, very important here, because here your software may be very good, right? It may have all the features, but the person who is configuring the software, if he lacks the knowledge, then it's going to create a problem. Okay. So attackers will often attempt to exploit unpatched flaws or access default accounts, unused pages, unprotected files, directories, etc. So security misconfiguration can happen at any level of an application stack. So the application server comes with sample applications that are not removed from production server. So those needs to be removed. Directory listing is not disabled on the server. Okay. The application server configurations allows detailed error messages. A cloud service provider has default sharing permissions open to the internet by other CSP users. So these are some of the examples for security misconfigurations. So the solutions are: go for Django hardening. That is, don't go for default settings. Change everything. Okay. Change the default directory structure. Then disable directory listing. Then use automated scanners. The one which I had shown, it's the most basic one, that is DJ checkup. Then customize error messages to hide sensitive information, because error messages also reveal some information. They basically reveal the system information. Okay. So instead of that, whenever such and such an error occurs, customize it and display a plain message. The next is cross-site scripting. So here the application uses untrusted data in the construction of the HTML snippet, so without validation or escaping. So here what happens, let's assume that there is a text field and you are writing some small code, small JavaScript code, and it gets executed. If it gets executed in the text field, that means that cross-site scripting is vulnerability is present. Okay. So here, if you see the example on this slide, here the attack causes the victim's session ID to be sent to the attacker's website, allowing the attacker to hijack the user's current session. Okay. So attackers can use accesses to defeat any automated cross-site scripting forgery defense the application might employ. Now, to protect against cross-site scripting, use Django templates, okay, which can protect you against access attacks. But there are some exceptions. Say, for example, you have HTML code, and in that HTML code, you are mentioning the JavaScript code, such as var in double curly braces, right? So you cannot achieve complete solution here. So it's also important to particularly careful when you're using eSafe custom template tags, the safe template tag mark safe, and when auto escape is turned off. You should also be careful when storing HTML in the database, especially when that HTML is retrieved and displayed. The next is insecure deserialization. So applications and APIs will be vulnerable if they deserialize hostile or tampered objects supplied by an attacker. So this can result in two primary types of attacks. One is object and data structure related attacks, where the attacker modifies the application logic and achieves arbitrary remote code execution. So if there are classes available to the application that can change the behavior during or after deserialization. Then typical data tampering attacks such as access control related attacks, where existing data structures are used but the content is changed. So serialization may be used in applications for remote and interprocess communication, wire protocols, web services, caching, or for persistence databases, cache servers, HTTP cookies, HTML form parameters, and so on. Now, to protect against insecure deserialization, the only safe architectural pattern is not to accept serialized objects from untrusted sources. If it is from trusted sources, you can accept. Then implementing integrity checks, such as digital signatures, will help. Then enforcing strict type constraints during deserialization. Then isolating and running code that deserializes in low privilege environments. Then log deserialization exceptions and failures. The next risk is using components with known vulnerabilities. So component heavy development patterns can lead to development teams not even understanding which components they use in their application or API, much less keeping them up to date. So components typically run with the same privileges as the application itself. So flaws in any component can result in serious impact. So such flaws can be accidental. For example, coding error or intentional backdoor in the component. Now, to achieve protection against vulnerabilities in the components, there should be a patch management process in place to remove unused dependencies, unnecessary features, components, files, and documentation. Then continuously inventory the versions of both client side and server side components. Then only obtain components from the official sources over secure links. Use tools like Shodan and Djangohunter. So here I would like to add one more point. That is, the Django framework is by default secure, and it has got very good documentation with respect to security. But we also know that many components have been developed by third parties. So we don't know whether they are aware of secure coding practices or no. So it creates a problem. So that's why you should make sure, right, to use the valid component. Then insufficient logging and monitoring. So exploitation of insufficient logging and monitoring is the bedrock of nearly every major incident. So attackers rely on the lack of monitoring and timely response to achieve their goals without being detected. So one strategy for determining if you have sufficient monitoring is to examine the logs following the penetration testing. So the tester's action should be recorded sufficiently to understand what damages they may have inflicted. So to protect against insufficient logging and monitoring, you should have appropriate logging and monitoring tools in place. Right? Ensure all login, access control failures, and server-side input validation failures can be logged with sufficient user context to identify suspicious or malicious accounts. Then ensure that logs are generated in a format that can be easily consumed by centralized log management solutions. So logs are very, very important. So they tell you what has happened in a sequence. It can also be used in forensic analysis, where the forensic experts can reconstruct the entire incident. So now we have covered OWASP top 10 issues. Let's see the tools in brief. So the first one is the Djangohunter tool, which is designed to help identify incorrectly configured Django applications that are exposing sensitive information. So this is the command. You can use Python 3 djangohunter.py and specify shodan key. So unfortunately, shodan is not free. The basic key is free, and you can use Google Docs, right? So here we want to check disallowed host key errors and operational errors and page found, right, at the root. The next is the Django Goat. So Django Goat is the intentionally vulnerable Django app to help Django developers to learn security testing. So similarly, if you want to learn security testing with respect to other applications, you can just search that. Say for example, Web Goat or PHP Goat and so on. So Django security resources. So collection of Django security resources, you can just visit this URL, right? So it has got the huge list of awesome security resources related to Django. Then Django security documentation, which is really awesome. Then in summary, since Django is a web framework and it maps to OWASP top 10 vulnerabilities, it has built-in modules to build secure Django web applications. Security of the application and data is not only the responsibility of the developer, the user is also equally responsible for the security of the data and accounts. Thank you everyone for your time and listening to my talk.